Welcome to this tutorial on interactive co-simulation using SimLab Composer and SimLab VR Viewer. With the co-simulation feature, you can control simulations directly from the viewer. The viewer sends commands to SimLab Composer, which handles the necessary calculations and updates the transformations of the solids in the viewer. By the end of this video, you'll be able to manipulate simulations through a bidirectional WebSocket connection. In this tutorial, we will open a simulation model from the Simulation Workbench library. Configure interactive controls. Import an environment. Set up the logic in the dynamic builder for co-simulation. Export the simulation to a VR package from the Simulation Workbench. And demonstrate the co-simulation at the end. Let's get started. Switch to the Simulation Workbench. Open a simulation model from the library. Simulate the model to observe how it behaves. Stop the simulation. In order to control a simulation interactively using a keyboard or Xbox controller within Composer, or to control the simulation in Viewer, it is necessary to configure the interactive controls. Go to Interactive, Design Panel. Look for the motor link. Click plus. Select it. Add a control function. Set up the control function to speed, and give it an identifier. I will give it the identifier, motor speed. Memorize or copy this identifier for later use in the Python scripts we will write in the dynamic builder, as we will need it. Assign tab and space as the increase and decrease keys, respectively. These keys are required to control the simulation from SimLab Composer. Set the minimum value to -50 and the maximum value to 50. This determines the operational range of the motor from -50 to 50. Retain the initial values for step size and default value. To control the state of the motor, on or off, add a state control. Give it an identifier. I will give it the identifier, motor state. We need to save this identifier for later use in the dynamic builder when we write the Python scripts. Assign the key E and the key D to the on and off states, respectively. Click OK. Simulate the model interactively to test the new controls, and verify if they respond correctly to the keys. Stop the interactive simulation. Before switching to the VR workbench, we also need to copy the last information that we will use later in the dynamic builder. Go to co-simulation, attempt to launch the WebSocket server by clicking on the option Open Server. In the local server information, copy the WebSocket URL. Because again, we'll need this in the dynamic builder. Switch to the VR workbench. Import an environment. Reposition the environment so the engine model sits on the table. Set start position. The imported environment comes with a sequence animation for a slider. Play it to observe the animation. To control the speed of the simulation from the viewer, let's add an interactive element by making the slider as a grabbable sequence. Connect a variable to the sequence by creating a variable of type number, named motorSpeedVar, and that to store the grabbing value, 0 to 100. We will use this variable in the dynamic builder. Now, with all of the elements in place, let's open the dynamic builder and start building the logic for the co-simulation. At the time of recording this video, the dynamic builder has 3 nodes dedicated to working with a WebSocket server and clients. They provide an implementation of the WebSocket protocol, enabling real-time bidirectional communication between a server and clients. The response, open external connection. The response, send message. And the event, on message received. First, we need to connect to the WebSocket server, once the scene is opened by the viewer. Use the Open External Connection node to establish communication with the machine that has the WebSocket server running. Create a string source node, and paste the WebSocket URL copied from the dialog local server information. For the slider logic, connect the variable changed node with the variable assigned to the slider sequence. Link the variable motor speed var to the variable changed node. Enter the Python script. Note how the script subtracts 50 from the variable motor speed var, and that to remap the slider's input range from 0, 100 to the motor's operational range of -50, 50, as defined earlier in the interactive function control settings. Use the send message node to transmit this value to SimLab Composer. For the buttons logic, set up the buttons to control the motor link state. Configure the white button to enable the motor link state, and the red button to disable it. Now, let's switch back to the simulation workbench to export the experience to VR package, and start the co-simulation. Go to co-simulation, then export VR package. This option exports the simulation as a simulation-compatible VR package. Ensure you export using this option from the simulation workbench. Now, we are ready to run co-simulation. Open the WebSocket server. If the server is open, the option will be changed to Close Server. Navigate to the saved VR package and run it. Start the passive simulation to test it, in co-simulation mode. Now, run interactive co-simulation, and start controlling the simulation in the viewer, this time using the controls located on the table. Changing the state of the motor in this simulation may result in breaking it. You can stop it, then start it again as needed. You have now mastered the interactive co-simulation. With SimLab Composer and VR Viewer, you can create immersive, real-time controlled experiences. Experiment with other variables, environments, or control devices to expand your simulations further. For advanced workflows, explore additional nodes in the dynamic builder or integrate custom Python scripts. Thanks for watching.